A and AS level mathematics. Lesson 6. Solving simultaneous equations by substitution. And in some cases one of the equations is going to be a quadratic. Also looking at the intersection of a line and a curve. So let's solve these simultaneous equations by substitution. Now, because the first equation has already got y as the subject, we'll substitute it straight into the second equation. Where the second equation says 2y, we'll substitute this term for the value of y. Now let's remove the brackets. 2 times 2x, 2 times 1, (4x) and 3x is 7x. Subtracting 2 from both sides will get you 9, take away 2. Divide both sides by 7. Once we've got a value, we can substitute into either of the first equations. I think the first equation will be the easier. So y is 2x plus 1, 2 1s plus 1, 3. Now what in fact we've found is where these two graphs, if they were drawn, would cross. If we drew those two graphs, they would cross at the coordinate 1, 3. And that is in fact what we're doing when we work out simultaneous equations. We're finding where the two graphs, if they were drawn, will cross. Now if I was presented with this question in an exam to solve, and I was left to my own devices to decide which way to solve it, I wouldn't use the method of substitution. I use the method of elimination, and that's where we make either these two numbers the same by multiplying this throughout by 3, so we get 6x plus 9y equals 6, multiplying this throughout by 2, so we get 6x minus 8y equals 40, and subtracting the two equations, thus eliminating the x. Or multiplying this equation throughout by 4, so this becomes plus 12y, multiplying this equation throughout by 3, so this becomes minus 12y, and adding the two equations, thus eliminating y. But for this exercise I'm being told to solve this by substitution. So what am I going to do? I've got 4 possible options. Either I make x or y the subject of this equation and substitute it into this equation, or I make x or y the subject of this equation and substitute it into that equation. I can see no advantage really in any of those 4 different ways. So I'm going to take the first equation and I'm going to choose to make x the subject. Now I could choose the first or the second equation and make either x or y the subject. I'm going to subtract 3y from both sides and divide both sides by 2. So I'll divide the 2 by 2 and also divide the 3 by 2. Now I've made x the subject of the first equation, I'll substitute into the second equation that term for x. So instead of 3x I'm going to write 3 of 1 minus 1.5 y minus 4y equals 20. Removing the brackets, 3 times 1, 3 times 1.5 y minus 4y equals 20. Let's subtract that 3 from both sides and we'll get 17 over there, and this minus 4y minus 4.5y will give us minus 8.5y. Dividing both sides by minus 8.5 will give us y equals minus 2. I can then substitute this value for y into either of these equations. I think I'll substitute into the first one. So we get 2x plus 3y, which means 3 of those minus 2's, which is minus 6. Add 6 to both sides and divide both sides by 2. I've solved the simultaneous equations. In other words, if I drew these two graphs, they would cross at the coordinate x is 4, y is minus 2. Now the reason we're looking at solving simultaneous equations by substitution is as soon as you get a quadratic, or in fact another polynomial, substitution is likely to be the best way. So again, I can either substitute x or y into either of these equations by making either x or y the subject of either of these equations. This time there's definitely an advantage of using the second equation and making y the subject. But you can make x or y the subject of either equation and substitute it into the other equation. But as I say, in my case, I think I'll make y the subject of this by adding 8 to both sides and subtracting 3x from both sides. Now I'm going to substitute this value of y into this first equation. So instead of y squared, I'm going to write the term 8 minus 3x all squared plus the 3x squared equals 28. Now let's work out this bracket. Remember the quick way, it'd be better. We square the first term, 8 eighths is 64. We double the first term and multiply by the second term. In other words, 2 eighths is 16, 16 times 3 is 48, so we get minus 48x. And then square this last term, minus 3x all squared will be plus 9x squared. Now if you're not happy with that, you'll have to go the longer way round and write down the bracket twice and then multiply each part and tidy it up. No problem with doing that if you're happier doing that. Okay, so what have we got here? Plus that 3x squared equals 28. Now we've got a quadratic in x, and to solve that we write it so it equals 0. So we've got 12x squared there. We've got minus 48x there. And if we subtract 28 from both sides, 28 away from 64, in fact gives me 36, so I'll get plus 36. Now we need to factorise this quadratic. If we happen to spot that each of these are factors of 12, dividing this by 12 and getting 1x squared, dividing this by 12 and getting 4x, and dividing this by 12 and getting 3 will make our job a lot easier. Now we're going to factorise. Two numbers multiply together to give me plus 3 and add together to give me minus 4, so that's the business. So we get two answers from this. We get x equals 1 plus 1 and x equals 3 plus 3. We then substitute each of these values in turn into either of these equations. I'm going to choose the second equation, put x equals 1 into there. I'll get 3 times x is 3 ones are 3. 3 and minus 8 is minus 5. Add that 5 to both sides and I'll get y equals 5. Now let's substitute x equals 3. 3 3s are 9. 9 minus 8 is plus 1. Subtract 1 from both sides and I'll get y equals minus 1. In other words, if I drew this graph, they would cross in two places. They would cross at the coordinate x is 1, y is 5, and they would cross at the coordinate x is 3, y is minus 1.